A pair of parallel conducting plates separated by 50 centimeters. You can write down parallel plates and write two parallel plates like this, and the distance between them is 50 centimeters. Okay. The electric potential of one plate is 200 volts. 200 volts. Other plate is 450 volts. 450 volts. The proton travels from 200 flow to 450 volts. By some means, this proton is now moving like this. Okay. Because this proton is getting repelled by this, so it is moving like this. What is the field strength between the plates and the changing kinetic energy of the proton? Okay. Now what will happen? Field strength. If I want to find field strength, how do I find using potential difference in distance? Field strength is given by delta V divided by delta R. What is delta V? Delta V is 200 minus 450 or 450 minus 200. 250. Because everything is positive here. Because it's told about magnitude, need not worry about the sign. Divided by what is delta R? Distance between the two plates. 50 centimeter. It will now be equal to what? 5 per centimeter. If I convert this, I get 5 into 10 to the power of plus 2, and this is volt per meter or Newton per foot. Both are same. So it is 500. The answer is 500. So these two are incorrect. This is correct. Then change in kinetic energy. See, this is moving from a lower potential energy to a higher potential energy. Do you think it will accelerate? It will never accelerate. It will decelerate. The moment you say it's decelerating, which means what? This will have, at this point, it will have a very higher velocity, and as it goes nearby to it, it will have a velocity v2. Might be this velocity v2 could be 0 also, or it is lesser than v1, which means your kinetic energy final minus kinetic energy initial, change in the kinetic energy would be negative. So therefore the answer is B.